I know there's one definite one. I just want to make sure you feel comfortable with it. And it's number 11. Okay, so on number 11, they give it to you like this. So if I write this as a point, yeah, that's exactly right. And then make that a point, make it 3, 4. Okay, so that's the big error that students might make on that. And then we're trying to look. Oh, and that's all I want to say. Hang on. Let's do x1, y1, and x2, y2. Okay, so I'm going to find the slope. And then 4 minus 3, 3 minus 1 gives me 3 over 2. That's my slope. Did I do that right? I hope. Okay, so here's kind of goofy. Yeah. You can't take me anywhere. Okay. Yeah, you got that right. All right, so I want us to think about this for a sec. Okay, so if I use this point, I'm going to get y minus 3 equals 1/2 x minus 1. Okay? But, my friends, hey, thank you very little. Yeah, he's here. You need escort?
No.
Okay. No, not you. You'll find out. All right. So, friends, let me ask you this. Notice I'm rewriting this over here. Okay? What happens if I plug this point in? Let me highlight these so you can direct your eyes. This and this are the exact same line. But I'm pretty sure y'all watched at least one episode of Sesame Street at some point, and those don't look the same. Do you agree? Everyone feel comfortable saying, I agree. Hey, I see a couple people with phones, so let's hurry up on that stuff and take care of last second stuff and put them away. Okay, so does everyone agree that these two things do not look anything alike? I mean, they have the same slope. You agree with me? Okay, it's a little kind of goofy, right? Now I'm not going to give you, if I give you a problem like this, I won't mean to. I'm going to distribute 1/2 over, and I'm going to leave it as a fraction, so minus 1/2. You agree so far? Then I'm going to add 3 to both sides. So 3, I'm going to change to 3 over 1 times 2 times 2. So that's 6 over 2. So -1 minus, or -1 plus 6 is plus 5 over 2. Okay, that's an ugly one to graph. That's an ugly one to work out. But I just want to show you, if I do the same thing with this one, I'm going to distribute the 1/2 over. Do you agree with that? And then I'm going to add 4 to both sides. Oops. Let's just, already distributed. Sorry. If I add 4 to both sides, so 4 is the same thing as 8 over 2. -3 plus 8 is positive 5 over 2. Are these the same? Yeah. So even though there's 2 different answers to give here, if I just ask for point slope, stop there. Don't panic if you're working together on an assignment and one of you chose one set of points. So I got this for an answer, but you got this for an answer. Okay, it happens. Just realize that both of your answers might be correct, and if you solve them both for y, you get the exact same thing. Okay? Was there anything else on page 167, 168 I can help you with? Feel good? Yeah. Number 6, yeah, buddy. All right. Problem number 6, we have m equals -4, and then we have this. Okay? So I'm going to call that x1 and y1. And I'm going to use point slope. And this one said, write the equation point slope. If given 2 points, find the slope, then use the first point listed. Okay. So then I'm going to go y minus 0 equals slope is -4 times x plus 3. Now, I could have this be a plus sign here, because 0, it doesn't matter if you add or subtract it, it's still 0. It's still not going to change. So that's how our answer would be written. Okay? Anything else from the homework? Feel good? Yeah.
Can you do 14?
Yeah. So we have a slope of 1/2, and then we have 8, -4. Write the equation of the line passing through the point, 2 points. Use point slope to set up the equation, then convert to slope intercept. So first thing I'm going to do is I'm going to use point slope. Okay, so that's x1 and y1. Plug them in. So the -4 becomes +4. Half x. The +8 becomes -8. So then I want to make this look like this. Okay, slope-intercept form. So I don't want any parentheses, and I don't want anything with the y. So first thing I'm going to distribute the half over. Minus half of 8 is 4. Then subtract 4 from both sides. So that looks like that now. Okay. Oh, I just want to give you all a heads up. Come first day, second semester, we go back to open seating so you find a seat. So if you like any of these comfy chairs, you better get here quick. Okay? Because these 3, they might not be here fast enough. After December, January 3rd or something like that. When we come back after break, right? After winter break, not after Thanksgiving break. Thanksgiving, we're still sitting there. So just in case you want to switch around where you sit, to get a different perspective. Yeah. It's the last week before winter break, so somewhere in that very last week, somewhere in there. I forget what the dates are. Yeah, it'll be everything for the semester. We have a total review and stuff like that we'll do prior. So we'll get that. All right, friends, do we feel comfortable with the homework? Everyone's happy? Content? All right, my friends, will you turn to page 169? Okay, this is on page 169 of your books. If you don't have your book with you, come grab a sheet of paper. Okay? So, friends, I have 2 lines we want to graph. One of them, I know that my y-intercept is going to be 0, 5, and my slope is going to be -2/1. So 0, 5 is up here. Slope is down 2, right 1. And, oh, that was horrible. So that's our first line. The second equation is definitely set up as a cover method. So 0, blank, blank, 0. So if I cover up our x value, notice what I just did. I get 2y equals -12. Divide each side by 2, so I get -6. So 0, -6. So there's my first point. My second point, this is a y value, so I'm going to cover up my y value. Notice they had it flip-flop, so we had to kind of use a little critical thinking. So 4x equals -12 divided each side by 4, so I get -3. So my friends, what do you notice between the red and the blue line? Do they look like they will cross? No, they're parallel. They're parallel to each other. So one thing to know, these are parallel lines, which means they have the same slope. Okay? Same slope. Now, it doesn't look like they have the same slope when you look at it because I can't really identify the slope on the second equation unless I solve it for y, but they have the same slope. So parallel lines don't cross. Okay? Some good so far? And then it says, what do you know about these lines? We already talked about it. They're parallel. Oh, get both equations in the same form. Okay. So I'm going to take this top equation. Now I'm going to subtract 4x. Then I'm going to divide everything by 2. Okay? So now this is in the same form. So notice the slope here is negative 2 over 1. And the slope here was also negative 2 over 1. That right there verifies for us they are parallel. Okay? So same slope. If you have two linear equations, you have the same slope, they are parallel. They will not intersect each other by definition. Okay? When you get to really weird math classes called like abstract algebra, which is like 12 math classes from now, they start graphing lines not on the XY axis, but they start graphing lines on something called a nape, which is basically, ready? This is how a nape is made. See my fingers? Let's draw a line. We're going to hold the center where my fingers were. We're going to hold that constant, and we're going to do this. So a nape actually looks like this. And you start graphing on stuff like that, which means all parallel lines intersect, but you don't have to know that. That's just bonus footage of Stirrups class. Bonus. So if they ever come and say, hey, what's a nape, N-A-P-P-E? It is conical sections. It's how you get parabolas and hyperbolas and ellipses and circles. All right, core concept, I know this is another. Parallel lines and slopes. Two lines that are in the same plane, meaning I graph them on the same graph, that never intersect are parallel lines. Non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel, okay? All vertical lines and also all horizontal lines. But all right, so problem number 1. Which of these lines are parallel? How we can figure this out? Oh, okay, well, let's do this. This goes down 1 and right 1, 2, 3, 4, 5. The red one, this goes down 1 and right 1, 2, 3, 4. And the green one, this goes down 1 and right 1, 2, 3, 4, 5. Okay, so the green and the blue are parallel. That's the symbol for parallel. Two lines that are parallel, kind of slanted. Okay, so the blue and the green are parallel. The red is not parallel, even though it kind of looks like it. We know it's not parallel because the slope is negative 1/4. Negative 1/4 is not the same number as negative 1/5. Okay? All right. Question number 2. Write an equation that passes through the point 5, -4 and is parallel. So what is the slope of this equation? 2 over 1, or just 2. Can I just write 2? You're absolutely right saying 2 over 1, but is 2 still the same thing? Okay. So then, it says write an equation. The nice thing is if it says write an equation, we're just going to use point slope and plug it in. So this is x1, this is y1. We're going to plug them in. So our -4 becomes +4. Our slope stays the same. X minus our x value is positive, so it's going to be negative. This is the equation that's parallel to 2x plus 3. That is also the equation that contains the point 5, negative 4. Oh, yeah. A little bit better. May I move on? So then they say, hey, we have a line that crosses through these points, and we have a line that passes through these points. So I'm going to label this one x1, y1, x2, y2. I don't need to find the equation. I just need to know, would these lines be parallel? So I'm going to find the slope of both. So I get negative 1, minus 3, negative 6, minus 5. So on top, that's negative 4. On bottom, that becomes plus over negative 1. So I get a slope of 4. The same, I'm going to do the same thing here. x1, y1, x2, y2. So I'm going to get negative 7 minus negative 2 over 2 minus 3. That is positive. So that's going to give me negative 7 plus 2 is negative 5. 2 minus 3 is negative 1. That gives me 5. Is 5 the same number as 4? No. Slopes are not equal, so not parallel. Okay? My math do okay? Cool. Huh. Write an equation that passes through this point. So that's an x1 and a y1. And is parallel to this line. What's the slope of this line right here? What's the slope of that? 1 over 4. Very good. So again, it's asking just for the equation. It didn't say put it in slope intercept. So I'm going to use our point slope equation. And I'm going to plug our values in. Our positive 2 is going to become a negative 2. Our slope is going to stay 1/4. My negative 4 becomes positive 4. This equation is parallel to the given equation. This equation also contains the point negative 4, 2. So if I graph both of them, they don't cross. The new equation would have the point negative 4, 2 as part of the line. Am I doing okay so far? All right. Graph these two lines. Okay. Y-intercept at 0, 5. Slope of 1/2. This one's set up to do cover method. So 0, comma, blank, blank, comma, 0. All right, so this is an x value, so I'm going to cover that up. So I get 2y equals negative 6, so y equals negative 3. So 0, negative 3 is down here. And then I'll do this one. This is a y value, so I'm going to cover that one up. Notice I'm going out. It's out of order from what we're used to, but just realize what we're looking at. Divide each side by 4, so I get negative 3. Dude, did I make a mistake? Yes. So that was wrong, wasn't it? That should have been a 12, right? That should be negative 6. Oh my goodness. Can't take stirrup anyplace. Then the negative 3 looks fine. All right. So friends, do those two lines appear to cross? So you can guarantee they're not parallel, agree? Do they cross with anything that looks significant? They cross at a 90-degree angle. This means these lines are perpendicular. Perpendicular, C-U-L-A-R. Perpendicular. That means they cross at 90-degree angles. Okay? So, perpendicular lines will not have the same slope. They have different slopes. What do you notice about the two lines? They cross at 90 degrees. Okay. So, perpendicular lines and slopes. Two lines in the same plane. That means you drew them on the same graph. That intersect to form right angles. A right angle is a 90-degree angle. Are perpendicular lines. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. So we're going to have to talk about what that means. Vertical lines are perpendicular to horizontal lines. So vertical line, horizontal line, they make 90-degree angles. They're perpendicular. Okay, so line A has a slope of 4. Agree? Line B, I don't see the slope right away, so I'm going to subtract x. Divide by 4. So y equals negative 1 over 4, x plus 3/4. This is the slope of the blue. This one in green, I need to solve it for y. Divide everything by negative 8. Those cancel. 2 over negative 8 is negative 1/4 minus 2. So the slope here is negative 1/4. Okay? So these two lines are parallel to each other. This and this are perpendicular, and this are perpendicular. This means perpendicular. Okay? So let's talk about what a reciprocal is. How do you spell that? Reciprocal. Negative reciprocal. So if you have a slope that's 3 over 4, the perpendicular slope would be negative 4 over 3. Okay? If you had a slope of 7, the perpendicular slope, you have to first realize that 7 is the same thing as 7 over 1, would be negative 1/7. Okay? So reciprocal means I flipped it over. It flips over. If it's positive, you change it to negative. You change it, make it positive. Okay? So we move here. Write an equation of a line that passes through the point negative 3, 1, and is perpendicular to this line. So the slope of this line is 1/2. So what does the perpendicular slope have to be? What's the reciprocal of 1 over 2? 2 over 1. What's the opposite of positive? Negative. So this has a slope of negative 2. All right, I'm going to use my point slope equation. This is my x1, this is my y1. So I get y, that was a positive 1, it's now going to be a negative 1, negative 2. It was a negative 3, it's going to be a positive 3. This line is perpendicular. It also contains the point negative 3 comma 1. So perpendicular, it's going to cross. It's going to cross. The crossing forms a 90-degree angle when it crosses. Oh, wow. We have, let's see, 7. Right, an equation passes through negative 3, 5, and it's perpendicular to this. So what's my slope of this line? What's my slope of this? Negative 3. It's also the same as negative 3 over 1. Perpendicular is going to be 1/3. Notice it's positive. So I'm going to use this. This is x1, y1. Plug into point slope. So I'm going to get y minus 5 equals 1/3 x plus 3. This line is perpendicular to the given equation. It also goes to the point negative 3 comma 5. And this helicopter. Let me see if there's anything remotely close to this. No. We're going to skip this one. All right, so I would like to give you a nice amount of time to work on this, and I'll help you while we're here, or if you come in an off period. But pages 171 and 172, we will be checking off on Monday. What time are we out of here? 11. Sweet. I'm giving you guys some time. Sweet. All right.